Hey guys, I am Sachin. I am from Computer Science.
Hey guys, I'm Chetan. I'm from Computer Science.
And we are from
MSRIT.
Hello guys, in this tutorial we'll walk you through the use of Code Composer Studio tool for MSP430. It is basically a tool for testing and debugging applications which is built especially for MSP430. But before that, let me give a heads up as what is MSP430 actually. So guys, now welcome to the world of MSP430. Ever wonder what are embedded systems? Suppose that you ask people in the developed world to show you the products in their house that contain computer chips. Probably they would point to a personal computer and stop right there. If you tried harder, you might be offered a game console or a personal digital assistant. It is unlikely that they would mention cellular phones which contain a startling degree of processing power just for communication, to say nothing of taking photographs and playing games. There is hardly an electrical consumer that product nowadays does not rely on digital control. This seems reasonable for washing machines and video recorders, but one might just wonder why a toaster or a kettle needs any digital electronics. The solution is these products contain embedded electronic system. So MSP430, where does it fit? Basically, an enormous number of microcontrollers is available. MSP430 is one among them. So an MSP430 launch development board launch kit is looking like this, especially this the red board with so many number of pins and configuration outputs and inputs. So MSP430 board was introduced in the late 90s, although its ancestry goes back to the 4-bit TSS400. So in a summary, it's a particularly straightforward 16-bit processor with a von Neumann architecture designed for low power applications especially. The CPU is often described as a RISC, that is reduced instruction set computer. So let me give a brief background about the data bus and the control bus, assuming that you already know the background of data and control buses. So both the address and data buses here are 16 bits wide. The registers in the CPU are still 16 bits wide and can be used interchangeably for either data and or addresses. This makes the MSP430 simpler than an 8-bit processor with 16-bit addresses. Such a processor must use its general purpose registers in pairs for addresses or provide separate wider registers. So this MSP430 here we are considering only for 14 pin configuration. So let me get into the architecture view schematic of MSP430. So here it looks like Launchpad development board schematic of MSP430 board. So here let me first go through the chip pinouts. So what are all the basic pin configurations which are represented and available for a user to develop applications. So the outside view pinout. The pinout shows basically which interior functions are connected to each pin of the package. Perhaps the most obvious feature is that almost all pins have several functions. This is typical of a modern small microcontroller. Silicon is cheap, but pins are expensive. The aim is therefore, as you all know, to integrate as many functions into as small as a package as possible. So most applications do not use all the peripherals. So with your good luck, there is no conflict where a design needs more than one function on a pin simultaneously. So that to avoid ambiguity. So here, these are all the pins starting from P1.0, P1.1 to P1.7. So let me walk through the pin configurations here. So here the VCC and VSS are the supply voltage and ground for the whole device, that is the analog and digital supplies are separated in the 16-bit package. And as I told you, P1.0 to P1.7 here, P1.0, P1.1 to P1.7 here, P2.6 and P2.7 are for digital input and output grouped into ports P1 and P2. And T asynchronous clock, TA0 and TA1 are associated with timer A. T asynchronous clock can be used as a clock input to the timer, while TA0 and TA1 can be either inputs or outputs. These can be used on several pins because of the importance of the timer which we basically use for clock frequency. A0 minus, A0 plus, and so on up to A4 plus or minus, which are available are the inputs to the analog digital converter. It has four different channels, each of which has negative and positive inputs. Vref is the reference voltage for the converter, which is available. And S clock, SDO, and SCL are used for the universal serial interface, which communicates with external devices using the serial peripheral interface, that is SPIR, inter-integrated circuit, that is I to C bus. Next we get X in and X out are the connections for a crystal. Here there is a crystal pads which are pointed out in the launch development board here in the diagram. So X in and X out are the connections for a crystal which can be used to provide an accurate stable clock frequency. The clock frequency is used when you build specific applications for any specific context. So RST here in the sense here RST is a reset. Reset is an active low reset signal. Active low means that it remains high near VCC for normal operation and it is brought low near VSS to reset the chip. Alternative notations to show the active low nature are RST and bar RST. And we have NMI. NMI is the non-maskable interrupt input, which allows an external signal to interrupt the normal operation of the program. And TCK, TMS, TClock, TDI, and TDO, and even test form the full JTAG interface. JTAG interface is basically used for the debugging purpose when you have already built or in the progress of building the applications used to program. That is debug the device basically. So we have one more, that is SBW TDIO and SBW TCK provide the SPI by-wire interface, an alternative to usual JTAG connection that saves pins. That is the JTAG which I mentioned recently, which is used for debugging purpose. So this is about the pin configuration which is available, that is there the input or output pins which are available for us basically. So next we come here for USB emulator connection. So USB emulator connection is basically used for connecting your Launchpad development board with your system. That is either your laptop or the desktop processor when you start coding or debugging your application. So here you connect a USB port and from here to your system. And here comes the power button, that is P1.3. The power button is used to switch on or off the entire Launchpad development board. So the next comes here the LEDs and jumpers P1.0 and P1.6. Here we have basically two LEDs, that is inbuilt LEDs which we have been given along with the Launchpad development board. That is the first LED 1 is synced with P1.0, that is P1.0 pin, and other LED is synced with P1.6. So either depending on whether you enable or disable the pins, you can activate or disable the LEDs respectively. So the next comes the reset button. So reset button as soon as you compile your code, so that you can use the reset button in the Launchpad development board to reset the entire Launchpad configuration back to the original mode. So that is the default mode, so that whichever applications you ran before the current compilation gets popped out, so that the launch development kit is starting initially. So this is the power connector pins here, ground pin as well as the VCC, which is used to supply the power, that is the power supply for the launch development board to run. Then comes the main part, one of the main parts, and we consider usually the main part and socket of launch development board of MSP430. So this is basically uh, standalone ZIF socket target boards. So what they are used basically for, program and debug the MSP430 in system to JTAG interface, through the JTAG interface actually. So this is basically for debugging as well as the configuration of memory, timer, clock frequencies, etc. So here, as we have represented this, that a separate diagram, these are the main component, that is the main characteristics which represent this main component. That is, it has 16 KB flash memory, 512 bytes of RAM, two timer, A3, 8 channel compartment underscore A, 8 channel ADC, and USCI. So this is about the one of the main component. And let's come to the crystal pads. What are crystal pads? So MSP430s have inbuilt 32 kilohertz clocks. So you might be wondering why a real-time clock is based on 32 kilohertz crystal, that is 32,768 kilohertz to be precise. So 32,768 is exactly 2 power 15, as you know, and this number can be easily divided down using binary values, two binary values to give you a frequency of 1 hertz or a period of 1 second. This is why 32 kilohertz is the standard frequency used in real-time clocks. As you know, the frequency of any system is measured using the clocks, right? So that's why the standard unit time, which we get as 1 hertz or a period of 1 second. So these are about clock frequencies. This is the crystal patch. And coming to 6 pin, is it 430 connector? So basically, EZ430 RF256X is a complete TI Bluetooth evaluation. So whenever you connect any Bluetooth interface to Launchpad development board, that is when you are using any Bluetooth specific application in your context, and if you want to connect that Bluetooth device to your Launchpad development board, so these pins are basically used here. And here are the embedded emulation part, which comes in inbuilt chips for representing the power supply, memory division, buses, etc. So basically you need to focus slightly on these pin configurations, especially before starting developing or coding any applications, because these pin configurations you should be knowing where to connect. Suppose you cannot connect to ground instead of VCC, because the launch development board may short circuit and the board may fail in functioning properly. So you should be knowing each of the pins properly. So this is all about the pin configuration, folks. And let me introduce you now to how to code actually using the Code Composer Studio tool for building any applications for on MSP430.
Let me start with the second session of use of Code Composer Studio for MSP 430. So today what we're going to do is blink our LED, especially uh, this one, that is red one, that is LED 1, which is configured to the pin 1, that is a bit 0 of the pin 1. Uh, okay, let me quickly start the Code Composer Studio. Yeah, Core Composer Studio is an Eclipse-based developing environment, or you can say integrated development environment. When you click on the Code Composer Studio exe, you got a workspace launcher. The workspace is essentially a folder that stores our all Core Composer projects. A workspace contains your settings and preferences as well as links to the project. Okay, so you can see a browse button here. From that you can choose the location where you want to store your project. So I have already created a directly called Code Composer. So and let me hit OK. So this may take a couple of seconds to pop up the window. Yeah, as we see, we are first time launching the Code Composer exe. You can see the welcome window, which contains a couple of things like creating a new project and examples, import project and support features, and for installation purpose and for getting started with Code Composer Studio, you can see a video down here. Okay, and a couple of things here you can explore in Code Composer Studio. That is by clicking this little buddy here, that is the restore button. You can see two windows down here, that is Project Explorer window and the problem window. The Project Explorer window is where our active Code Composer projects are visible. So problem windows is particularly important when we are doing a debug or a compile session. So let me quickly create a new project down here, and this is new. Go to file, click new, and new CCS project, that is Code Composer Studio project. So you can see a pop-up asking the project name. Let me give that project 1. Okay, so as we are developing this code on MSP430, the family is MSP430, and the important thing is to select the variant. So as we are using the MSP430 family, you can we have MSP G2553 variant that we are using. So exactly why MSP430 G2553 variant is using is this is a device that comes pre-populated with MSP430. So the connection is as usual the USB one, and let me take an existing project, that is the blinking the LED, and let me hit finish. Yeah, uh, if you explore the project in the project explorer, you can see a couple of files here, that is the include one and link.cmd. So why especially let me say when you are accessing some of the features of some devices, let me take an example of MSP430. So you need some of the files to access the feature, that is the device specific header files and device specific linker command files. So you can see those two files down here, that is in include files you can see all header files that are needed, and in the cmd files you can see uh, linker files. So what exactly the linker file does is specifies the device memory map for the linker, and so the linker knows how to place your code, that is the program and data, in the memory. So let me before going to the debug session, let me quickly go through the codes. So in the main function you can see the first line. What we are doing here is we are stopping the watchdog timer. So what it helps, actually it helps to prevent our program to get stuck in a place where it shouldn't be. For example, you can imagine a scenario of an infinite loop. So what it does exactly is just resets the device after a certain period of time. Okay, so then we will move on to the next line of code, that is P1dir, which is a register that configure the direction of port as an input port or an output port. So as you see, as you saw in the first session, that we have 8 input output pins. So that is what we have done here is 0x01. That is what we are exactly, that is especially blinking the LED one, which is configured to the pin 1. So what we have done is, if we have a 8 pin, you can say 0 0 0 0 and 0 0 0 1. From left to the right, it's 7 6 5 4 3 2 1 and to 0. So we have made the 0th bit of the pin 1 as 1, so that we can blink it. So as we move on the code, you can see infinite loop and very important line of code, that is p1 out, which is nothing but a toggle operation, where we can see a blinking like when you use an XOR operation. So it's nothing but if you have a 0 and you will get a 1. So if it's 1 and then it's off, uh, 1 and then it will be a 0. In that example, if you see the blinking of LED, it's like that only. So when you say 1, that is on, blink on, and after sometimes it will off, that is blink on and blink off. So this is the line of code that helps to toggle the LED. So let me click on debug straight away. Yeah, this is the project, and let me hit OK. Proceed. Yeah, you can see a pop-up saying that no USB FET was found. This is because we haven't connected our MSP430 launchpad yet. Now we have connected the MSP430 board to the PC. So let me hit debug once again. So it will take a couple of seconds to configure. Yeah, now I'm gonna hit the play down here. You can see the LED one, which is configured to the P1, that is the bit 0 of this pin. You can see the LED which is in MSP430 board is blinking. So here you can see some different kind of screen, or you can say a window that is specifically for debug. You can say it's as a debug view. So here you can, on the top right, you can see two perspectives. That is, first one is Code Composer Studio edit perspective, and the second one is Code Composer Studio debug perspective. You can toggle from debug session to the edit session. So in the menu bar, you can see a couple of buttons down here. That is the connection button. That's it's given option to disconnect the target. So as we have now connected. So if you come a little down, so you can have a resume button. When you hit resume button, it says it's device debugging. That is actually now the LED is blinking. So I will pause it, and this is to terminate this session. And you can see a couple of step into or step over buttons to move from one step to another uh, down there. And on the right half, you can see window. This is nothing but a watch window, that is specifically you can see if you have any of the variables or any expression that you have, you can see that. So like, as you can see in the code, you have a variable I. So for that I, you have its type and its value, and you can see that address also, and you have expression one and you have register one. So that's all from my side. Thanks for watching this video.